My name is Alexander Haller. I'm from Heidelberg University, and I'm going to present elAPI, which is an API client we wrote for eLabFTW. When I say we, I want to give a huge thanks and credit to Mahadi Xion, which should be in the audience today. And he is the main developer of elAPI. So I'm just presenting, and I'm basically giving input, but so like he's the expert on Python development and can answer all difficult questions. No, but again, thank you very much, Mahadi. What did we, or like where does elAPI come from? It wasn't from the need. We had a need for a simple API script for our internal use. It was the initial idea, and then it developed into a full-blown API client with plugin support and everything else. But so the initial need was internal, and then we had a really great developer who developed elAPI out from that. Our philosophy with elAPI is it says on the screen, but to make simple things easy and complex things possible. And for me personally, that means we aim to be a one-stop solution for everyone that wants to interact with the API of eLabFTW. You don't have to be like a hardcore API developer. My personal goal or success story would be if I can give a researcher a link to elAPI and say, hey, if you know Python, download the package elAPI, do elAPI init, and give your credentials and UL. And here is, by the way, here's an internal plugin reshare, and you can download it to your computer, maybe attach microscopy images to your experiments or do a daily backup of your experiments, stuff like this. If this is possible with elAPI to make the API more accessible to a wider audience, that would be the success story for me. And how did we implement this, or like how do we support this? We a lot of thought in elAPI went into designing it as easy as possible while safeguarding against common mistakes. Like I will go into this later, but so if you download something, it per default prepends the date, so you don't overwrite local files you might have, or it warns you if you have API keys in your project folder. If you it automatically verifies your URL, and you can validate against host names, which is great for developers. If you have a dev instance and a production instance, you can safeguard in your development process against like accidentally overwriting production or something like that. And it's elAPI is also a CLI tool, but it's also a Python library. So if you want to use all the features that elAPI has in your own advanced Python usage, it's you can just use it as a library. I will demonstrate this later. It's so you might ask, okay, eLabFTW also already has a reference implementation of the API elAPI Python, which is good. Like I argue that elAPI can do everything elAPI Python can, but we took a lot of work and added additional features that makes it more powerful and flexible than the official. So why our intention, or like why we did it. As an example, here's a quick comparison between elAPI and elAPI Python, which reads all the resource items from an instance. And what you can see, like in the elAPI Python example, there's a lot of boilerplate code. To be fair, like this code initially with the API key, the URL, the host, and all this stuff also obviously needs to be somewhere in elAPI, which is handled by a YAML file that's somewhere, and we also support, for example, but we support, for example, configuration overloading, where you have a system-wide configuration and you have a user home folder configuration and you have a project configuration in your project folder, and you could mix and match. Yes, you don't have to rewrite everything if you want to try your code on a new instance or you want to share your code with another person. It doesn't live inside the code. It also safeguards against that you commit your code to a Git repository or stuff like this. So under the hood, it's just following the official API specification. We also closely track and catch any updates here, and just use regular HTTP X library in Python to talk to the API. Here is an example screen of elAPI if you use it as a CLI tool. And roughly the sections you can see on the screen here are the meta and config sections where you have, for example, bash completion. Yeah, so if you want to use it in the shell, it actually can autocomplete your commands. You can very helpfully, we have a show completion command and show config command, just because we have so many sources where configuration could come from, that we provide an easy way to figure out, like, okay, what configuration am I actually using? I don't know, developers usually have like multiple servers and multiple API keys that you want to test. Okay, now I'm a regular user, now I'm a sysadmin. So this makes it very convenient to keep an overview of your configurations. And then the idea is we have a raw API. We call it raw API commands section. So any API endpoint you can just make in elAPI that's available in eLabFTW, and it takes just you don't have to type out a long curl or whatever command with your API keys. You can I in my day-to-day use just only use elAPI to make like raw API commands, which is much more simple and already has all my credentials and URLs and code and stuff like this, which is great. Then the next part would be we have built-in plugins, which then build on those raw API commands and provide an abstraction layer to those API commands. And this is also like one of the sections that we intend to grow in the future now, where we have, for example, the experiments plugin, and then we can just say to researchers, hey, run elAPI experiments, your ID here passed to your image file and upload an attachment. Yeah, it's a one-liner, very easy. And then third-party plugins. So if you want to write your own plugins, we have a really powerful and easy way how you can integrate this into elAPI. Coming to this later. Here's just a quick demonstration about all the thought process or the layers that go into elAPI, where, for example, one request we had in an earlier presentation or an earlier workshop was someone wanted to have a verify SSL option to disable SSL verification for local dev instances. It was a feature we added after feedback from a workshop. You can change your timeouts if you're on a slower, say you are a researcher with a poor internet connection somewhere in the world and you want to increase the timeout for certain commands, you can do this. We have safeguards in our development model that disable plugins that are non-working, for example. There, a lot of thought went into this safeguarding and supporting infrastructure. It's just an example. And now, like after all this, it's really easy. It's like one-liner, this terminal elAPI get items, format it in a certain format as a CSV in this file, and export it to a path, and that's it. Yeah, and you don't even have to give the export option because elAPI has a. If you don't give it, it uses a default one. So and it's also really helpful because elAPI knows what API endpoints exist, and it gives you feedback, or like it says, okay, you're using a command, but this command is not supported or understood, and it tells you here we do a call to get item format CSV export, and it says, okay, error, no idea, and the valid endpoints would be API keys config, etc., items. So you missed the S in item here, which is great, especially if you are not and the API main developer and you want to make a call. You don't even have to go into the documentation necessarily to see what valid endpoints exist in this call. And it obviously also catches if you want to use, if your URL is misformatted or your API key doesn't have write permissions, if you want to make a write call and stuff like this. So all this makes it very easy for, in this case, I would say researchers that want to get just like the experiment done, basically. And a more advanced example as a library, if you we have a custom class that gets information about any resource async, and it can pull everything faster than if you would make single calls again and again, like linearly, and it has full support. It also you can in the config you can enable HTTP2, which is experimental and can fail with if you go over like 100 or 200 synchronous calls, something like that. But we're very confident that that elAPI is like one of the fastest API clients out there if you use the correct classes.
Alexander, just to let you know, 2 minutes left.
All right. Thank you. You can't read the code here, basically, but this is an internal use case we had for our instance, which expires all accounts that belong to a certain team. Yeah, so after a team leaves, we initially go and expire all accounts. And what does elAPI do here for us? The yellow one restricts operations. So just for testing, it's on our dev servers. It validates that we have sysadmin access. Then it reuses the same session because it doesn't want to make a new call for each user. And it also has login, which it has a unified login infrastructure, so you know what happened if you run it in cron jobs. Third-party plugins, you can just drop your plugin into a shared folder and it shows up in the CLI also with help text and everything. And it also doesn't fail, like elAPI doesn't fail if a plugin misbehaves. It just fails the plugin and doesn't fail. For example, if you're running elAPI in a cron job to do certain things, it doesn't fail the whole system. Yeah, again, experiments example, appending a new log line, for example, elAPI experiments append. You give the ID to the experiment and the content. That's it, yeah. And we have internally the build teams, what we needed initially. where we generate billing information, and an experimental proof of concept where Mahadi used Selenium and logs into the elAPI eLabFTW instance, gets a cookie, and downloads statistics for the server. The time was very short, and we had to skip over many things. I encourage you to try it out. We recommend with all Python Python packages to run it in a virtual environment. We recommend pipx currently as a manager. So install it, run elAPI init, type your API key URL, and try it out if you have any questions. Thank you so much for listening. Again, also thanks Mahadi, who did the main work on this. And if you have questions, or if you have feature requests, or spot a bug, send us a GitHub pull request or comment or anything. Thank you.
Thank you, Alexander. That was perfect timing.
Okay, hello everyone. I'm Amir, and I'm representing Fermat here today, and I'm presenting you the integration we have on eLabFTW. So I'll briefly give you an introduction about what Nomad is, what are the main components of Nomad, which is essentially one of the features. Main features are the parsers. Then I'll walk you through the third-party integrations we already have, especially about the eLabFTW. Then I would like to give you a live demonstrations, and then at the end I'll show you some useful links that you can communicate with the Nomad community. So essentially, Nomad is a cross-platform, a web-based software that you can use it to share your data, to publish your data, give some with your colleagues, and specifically made for material science data. One of the main features of Nomad is the parsers. The parsers basically are Python code, Python packages that is already developed for certain softwares. So if you can come in with your let's say HDF5 file, and you can drop it into Nomad, and then it will be parsed based on your customized schema. We have already developed integrations for third-party ELM providers, such as eLabFTW, LabFolder, OpenBiz, and Kmotion, and the number is growing. So right now, I'll be walking you through the eLabFTW integration. So we expected to have two distinct type of users for a user that wants to transfer the data from eLabFTW to Nomad. We anticipated two users. One was the new user that kind of has no experience using Nomad before and just wants to play around and just, let's say, drag and drop the data and see how Nomad behaves and parses the data that the user have. And one other users are the advanced user that already have some idea about the data model, the data structure in Nomad, and the data structure of eLabFTW. So for the first type of users, the new users that just want to play around, since eLabFTW provides this ELN file format, so the user can just export the data into ELN file format and easily just drag and drop into a Nomad instance. They can use the global Nomad instance, which I will show you in a second, and have the data parsed into Nomad data model. And the second type of users who are more advanced, who has fairly knowledgeable about the data structure of Nomad and eLabFTW API response model, then they can use the Nomad. They can use the API key that eLabFTW provides. Then they can parse their data into Nomad. So let me give you a quick presentation of of how we can use Nomad to parse your data from eLabFTW. I have already, so you can use, so if you go to any experiments in your eLabFTW instance, we can export your experiment into ELN archive. You can call it, doesn't really matter, but you need to keep the format as .eln. That is essential. Okay, then you can go to your Nomad instance, whatever it is. Right now I'm using a local instance, but should be fine either way. So you can create a new upload, and then you can drag and drop your file into Nomad, and then it should be easily parsed. And then you can see your data that is already parsed. So the experiments, so you can see the body, and you can see all the data that is already in your eLabFTW experiment. And if you have any files that is already associated in your eLabFTW experiment, it's already downloaded and already saved in Nomad in Nomad backend. Also, for the second type of users who are who are fairly advanced, who already know a bit about the data model behind Nomad and behind the eLabFTW API response, they can use a YAML file or a JSON file. They can come up with their own schema. I have already put up the links at the end of the presentation. You can go and check how you can write a custom schema for Nomad and how you can link it to download eLabFTW. So here's one simple example. So you can pretty much, so this is in Nomad, you can define your schema using the definitions on top, and then give some kind of metadata to your schema, and then you just need to inherit from certain base sections, which is internally used in Nomad. And then here comes the anchor for Nomad to know where you want to fish the data from the API. So let me drag and drop. So this is a YAML file. So I'm gonna just drag and drop this YAML file in Nomad. So it will be successful. I'm gonna create now an instance of this schema. I'm gonna call it test. I'm gonna instantiate from this schema. Okay, so it's asking about the URL of your eLabFTW, which I have it here. So it doesn't really matter which experiment you're already on. So you can just take it. In case the API that you're using is different, the server is different from the main API here, you can specify it here. If it's the same, then you can just leave this API URL blank. And then there is a API key, which I have already stored it. Yeah. Okay, and then I'm gonna put on save, and here's what's gonna happen. So if you remember from the schema, so I had, so in Nomad we call this, we call quantities, we call let's say properties of your experiment quantities, and I'm calling it a title, and I'm expecting it to be in the response data. I expect it to be in the title. So I have a title, and you can see it's already parsed, which is reaction schema test elab, which is this one here on top. I can show you a bit more advanced stuff just for demonstration, so that you can have a longer schema which represents more parts of your experiments in your elab. I have already uncommented it. So in my Nomad, I'm going back and I'm going to start. Let me start a fresh one. I'm drag and dropping my schema file. And again, I'm creating another test case. And I'm going to do the same. And on save, it's making the API call and it's fishing all the data from that experiment. And you can see, for example, in your eLabFTW instance, in your experiment, for example, you have a radio button. If I go to the edit section, so it takes a bit long. So yeah, you have, for example, you have in your extra fields, you have a radio button, you have 3 options, then you can have the same. You can exactly map it to a radio button in Nomad as well. And you can have a drop down menu, you can have a rich text edit quantity, date time field, so on and so forth. So basically, I mean, there are more to it, but due to the lack of time, so I just stick to the main points for the integration we have already. And yeah, thank you for your attention.
Thank you so much, Amir. You're done ahead of time, so we have extra time for questions. Has anybody tried doing this yet? Migrating data into Nomad from eLabFTW. Everyone is shy today.
I think it's really a great example of the use of the ELN file format to move data from one software, which is eLab or can be another, and you gave some other example, to Nomad, which is a data repository. And I think what you showed is really great, because from the point of view of a user, if we just focus on the first part, not the second part where you have a custom schema, which might be too involved, I would say, for like the mortal people. You just drag and drop your file that you exported from eLab, you drag and drop it, and then everything is there. And that's exactly the goal, one of the goal of the ELN. So I'm very happy with that. With just one remark, you should write the documentation for that. It should be more publicized that this feature exists now that is, I guess, stable and public and everything, because I think it's really a great example. So thank you, Amir.
Yep. Yeah, no problem. We have already the documentation. It's already there for how to use our ELN integrations. So it's already on the screen. Yeah.
Okay, great. We can make sure to integrate that with the documentation for eLab. So we have 2 questions. One is from Josh. If you sync the data, what happens if it gets deleted in eLabFTW?
Yeah, so we are not kind of dynamically syncing the data unless the user wants to resync the data. That's what was this button for, the sync project. So basically, we're storing in Nomad repository. So if you lose it or if you delete it from the source repo, has nothing to do with Nomad repo. It's kind of, we're making a copy in our repo, but with our own data schema. But yeah, I mean, unless you go for a resyncing the project again, then yeah, you will be losing your data.
Nicola, want to add something to that?
No, it's just that I when I click answer live, I cannot say let Amir answer live. So that's why it appears like it's me, but no.
Okay. Okay, and Marcel asks, seems like one can edit in Nomad. Are the changes returned to eLab? So I guess it's related to the previous question.
Yeah, thanks for the question. Right now, it's not intended to have bidirectional connection. It just means to import data from eLabFTW and not having this bidirectional connection. It is potentially possible with Nomad, actually, but you can use Nomad plugins. It's a bit advanced, quite advanced, I can say. It is possible, but this one that I showed you here is not designed to have this bidirectional communication. Yeah.
Okay. And Hussein says, is Nomad open source and can you use SAML authentication?
It is indeed open source. For authentication, I'm not super sure. You can. I'm not super sure about if you can use single point authentication. I cannot. Yeah, I don't have it on top of my head.
Okay.
I'll answer later. Yeah.
Okay, we got another vote for SML if it's not currently supported. And then Stefan asks, can you show some features of what I can do with data in Nomad and like why use Nomad, I guess, as opposed to other data repositories?
Yeah, sure. I mean, you can go to Nomad. This is the main deployment. There are a couple more, but if you go to the main deployment and, for example, look for, I don't know, an entry. So you can see. I mean, this is main. I guess this is the simulation entry. I'm not really coming from with the background of physics, but you can just dump your data and then have it visualized, have it shared with your colleagues. I mean, run several parsers on top of it, write your own parsers, and again, and publish your data for your paper. So yeah, it offers a lot, and it's a repo basically. So you can keep your data here. Yeah, it gives you. I would say it gives you a lot.
I think one of the core features of Nomad is that it can parse a lot of files coming from different pieces of equipment that do a bunch of measurements. But it's really, really targeted, I would say, to the material science, like you said at the beginning. Yeah, and for material scientists, I think it's a great data repository.
Yeah, thank you.
Thank you so much for the opportunity to speak here. So I want to give you a little bit of like an insight what we are doing here. And the idea of my talk is more like a user story. So also you guys see what we are doing with your really, really nice piece of software. Yeah, so let's start. Next slide, please. So the idea is I'll give a brief intro on who we are and what we're doing. Then I'll talk about our hardware setup a bit. And by hardware, I mean all the machinery and the vacuum system we built so that you guys have a little bit of context on our needs or what we are doing. I promise, or let's say, I promise I try to be brief. If I'm too fast and you're interested in some of the machinery or the physics, then please feel free to ask me in the end. After making you familiar with our setup, I'll talk about our IT systems a bit. So the various servers we're using and how this ties into eLabFTW. And yeah, then a short outlook where I will present a few items that we have planned in the future. So you might tell me why this is a stupid idea or if there's already some nice plugin or piece of software that we could use for that. Yeah, thank you. Next slide. So brief intro on who we are. So we are a physics of nanostructured materials, Faculty of Physics, University of Vienna. I put all the logos there to do this justice. Group is run by Professor Yannick Kotakowski, and we have also a PI, Thomas Husi. I also put Yannick Meyer there because he basically kickstarted the lab. In total, we're about 40 people, and the machines I show you and the eLabFTW installation is basically just for our work group. So we are not a service facility or anything. It's really like our own research, which is on the next slide. So we're doing complex nanoscale matter, mostly two-dimensional or low-dimensional materials, and our weapons of choice, so to say, is electron microscopy and first principles modeling. If you don't care about all of that stuff, so I usually, when I give talks to the public, what I say is we look at individual atoms and see what they're doing to each other and to understand how the materials work and then try to make them even nicer and better by rearranging them or putting new atoms in place. Yeah, next slide, please. So this is where we're located. So this is a map of Vienna. So you can see the nice city center. Boltzmanngasse, where our main building is, and the red circle is Sternwarte, which means observatory in English. And this is where we set up all of our gear. You might ask, why do you go that remote? Well, if you set up electron microscopes, that's special. They are super picky about vibrations, magnetic fields, and that stuff. And the observatory is really, really nice in that regard. You will see in the next slide why. because the building is located in a huge park, which is protected by some laws regarding the conservation of old buildings. So nobody's allowed to build anything there. And we basically have quite nice distance to the next couple of houses. Yeah, next slide, please. I couldn't help but include a few pictures of the building because it's really nice and beautiful and 150 years old. On the right side, you even see a bust of our very old emperor, Franz Joseph. So if you're ever in Vienna, then come visit us. It's quite a nice place, actually. Yeah, next one. There's also a super nice old telescope. It's 150 years old and it's still working. Obviously not used for science anymore, but still in reasonable shape. Yeah, next one. So, okay. But now we'll start with our hardware setup. So in the basement of this very, very nice building, we put up a really, really nice scanning transmission electron microscope. I put all the details there for persons who are interested in machinery. What is nice is that we get nice atomic resolution with this. We can really, really nicely see individual atoms and see what they're doing. We have really, really good vacuum and added a couple of nice features that allow us to also do in situ experiments. I highlight here the PAC system because this is kind of important because this will later directly tie into eLabFTW. This is like some special sample holders we built so we could use them in different machines without, taking the samples out. What is also interesting is we recently got a really, really nice direct electron detector, which directly detects, as the name says, each individual electron, and it can go up to 100,000 frames a second, which of course, from the IT point of view, puts some challenges because this data needs to be stored and processed as well. Yeah, next one. So what we also have is an alteration chamber where we can put our samples in and change their configuration somehow. So you can put, new layers of atoms there. You can shoot your samples with a laser. You can hit your samples with ions or whatnot. So this is basically what we do to change the configuration of our samples. Why does somebody want to do that? You can think about a bit like doping. If you have a silicon crystal, it's kind of boring. If you dope it, then you get semiconductors, which you can use to do nice stuff with, right? Yeah, next one, please. So we also have an atomic force microscope where we can probe the surface of our samples and also do some mechanical testing. Next one, please. And this is super important. We have storage in ultra high vacuum for up to 72 samples. So at each moment in time, you have 72 samples in various vacuum chambers where you don't have physical access to. So you need to have some sort of IT system that helps you tracking your samples, because as you can imagine, with 72 samples and 40 people, if you don't have a sample tracking system, it's a huge, huge mess. Yeah, all of those chambers use the same PAC system, so you can put the sample from one chamber to the next, to the next, and to the next, which is really nice. And all of those are ultra high vacuum systems. It's actually one huge system. And what we managed to is to interconnect all of those with vacuum transfer pipes. Yeah, so that's the acronym for CANVAS. You need to give it a name: controlled alteration of nanomaterials in vacuum at atomic scale. Yeah, next one. And this is a cross-section and top view of the system. And as you can see, it really spans over 2 floors. And we managed to connect all our experimental gear with vacuum pipes to move samples back and forth. Yeah, next one. In case you're asking yourself how we did this, we designed small cars, looks a bit like Tron, and these cars run into the pipes. They are magnetically coupled, and each car houses 3 samples, and you can drive with your car from one machine to the other, even to the first floor with a cable car. We're Austrians, we like our cable cars. Yeah, next one. We also have a load log that's completely computer controlled for loading the samples. Yeah, next one. A glove box under argon atmosphere where you can manipulate your samples. Next one. And, do some transfers and load them in a car and then drive into your system. We use this for oxygen sensitive samples. So there is certain types of samples that immediately break if they're exposed to oxygen. And this way we can prepare them under argon atmosphere and then run them in our microscope, and they have never ever been exposed to air. Yeah, next one. So the sample storage system is actually 2 parking garages where all our cars are parked. So we need to also have some logistics so we know which car is where and what is in the car. Yeah, next one, please. To sum our system up, 72 samples, 24 cars, 2 garages in one huge 2-floor vacuum system, lots of experimental gear. And then we also have additional electron microscopes and optical microscopes for sample preparation and stuff like that. And all of this needs to be managed somehow. And this is why we started to develop our IT setup. I hope the first part wasn't too exhaustive. I'm like super stoked about the system. So if I've been talking a bit too much, I have to excuse myself for that. Yeah, so this is our IT setup. I decided to put all the systems we are using here. So maybe there is something interesting for somebody, for booking systems and stuff like this. In case you're wondering, Neon Swift is a really, really nice, written in Python, open source microscopy suite. So you can also use this for manipulating graphics and stuff like that. So you can think of it as Python's ImageJ or something. You can nicely write yourself plugins for controlling stuff. Yeah, we have a data server, and you see eLabFTW. We started using it in 2018. So I would say we're quite long-time users already. Yeah, development server and inventory server, just to, sum it up. I'll talk a little bit about the data server, how we do this. So what we do is the data server automatically connects to all of our machines that we have and downloads all the data automatically overnight. We have worldwide read-only access via SFTP with keys only, because I think it's super important to have raw data immutable. So, yeah, and then there's a backend storage Ceph cluster. This is a graphic, so you see how this works. If you do some IT stuff with networking involved, you always have to make a graphics. So this is roughly how it works. As a storage, we're using Ceph, which is nice software-defined storage. Okay, so this is our eLabFTW setup. We used to run it on a bare metal server, but recently moved to a VM. We set it up in a Docker container from the beginning. I guess nowadays it's the only way to do this. What might be interesting is it's only accessible via our internal network. I mean, it's a really nice piece of software, but we don't really want to have it on the internet. So what we have is a 3-node firewall cluster that creates a SOCKS 5 proxy via SSH. They run OpenBSD, and this is our way to go into this. This is why we are using this, and I took the liberty to copy and paste an email I wrote to Yanni, my boss, including all the typos and everything. Like in the beginning of 2018. That's back in the days, Nico, you're smiling, the points I found interesting and why we chose it. I don't read through all of this. I guess you can see the slide. I just want to highlight one. I wrote API, Python, and Bash. I hope we will have fun with this one. Yeah, and boy, was I right. So, yeah. How do we actually use eLabFTW? Usually when you're searching or using an electronic lab book, you want to replace something that exists physically in the first place. And if you do it right, you actually have to write, in my opinion, 3 logbooks. And this is kind of the pitch I also give our people when, I pitch the electronic lab book somewhat, so that people understand that it actually saves them a lot of time. Because usually you have a machine logbook, you might know that. This is these nice black books that are next to a microscope, and it says, if you use this device, you should write it in this book. And then you open the book, and the last entry is from like 2 years ago or something. So this clearly usually doesn't work. Then what you also need is a sample notebook, right? If you're dealing with samples, you want to have a history, what happened to your sample, and you need a personal lab book. So this is also these nice black books that people fill, like a journal book. And the cool thing for us, as we use it with eLabFTW, you get 3 for the price of 1, so to say, because what we do is we have these data types, and I highlighted the important ones in this case is sample, device, and person, and you can link sample, device, and person, right? And the cool thing is, if you click on sample, you get a list of all the experiments that happened to your sample. So this is your sample book. If you click on the device, you get the device notebook because you know everything that happened on your device, so you don't need this black book anymore. And if you click on the person, you get a list of your experiments. And for us, the device database also acts like a knowledge hub, so to say. So for all of the devices, we attach all the manuals and typical parameters and stuff like that. So the way we do this is if some person wants to use a machine that they are not familiar with, they should be able to just look at the device entry and should be ready to go. Yeah, we also do the sample tracking.
I'm just going to give you a 2-minute warning. Sorry.
Okay, yeah. So we do the sample tracking in eLabFTW. So we use the database ID for sample tracking. I now know you guys have this nice form of ID, but when we started using this was our only way, which is not super practical, but it works well enough. Why do we do this? eLabFTW already has support for QR codes. It's searchable and has a nice API, as you all know. And what we do is the QR codes we create for our samples and put on our sample boxes and with ID equals, and then the integer that is the database ID, and our scanning system chops off all the ampersands. So you could use our own printed QR codes or the QR codes from eLabFTW, and the software will know which sample this is. Yeah, next one. Quick thoughts about sample management. How, yeah, you know what, let's skip over that in the sake of time. This is just me philosophing a bit about how to do sample loading. So this is our sample loading station. You see it's a small Raspberry Pi with a touch screen and a webcam. And this is basically the heart of our loading system. We have QR codes on all our sample holders. We have QR codes on all our sample boxes. And the whole system is designed in a way when you swap your samples, you only scan the old sample box with a QR code, and you scan the new sample box, and the system automatically knows which sample is in which holder is in which car, and so forth and so on. And we use this by also, you know, talking to the Python API and to the eLabFTW API and getting the sample information. And that sample information is automatically relayed also to the microscope. So whenever you then go to the microscope, it's all there. I included a couple of screenshots how this looks like. You log on with the QR code, then you can scan for any parts of this. We can skip over this a bit more quickly. So this is just was the idea how this looks like a bit, and you can go and unload samples. And this would be a typical workflow, and this is basically my end. So you get a sample, or you create a sample somewhere. You create an entry in eLabFTW. It gets this ID. You print a QR code, stick it on your sample box. You hold it under the camera when you load your sample. You don't need to type anything. You do microscopy. You record your data. You write an eLabFTW experiment. You close and timestamp the experiment. Put the PDF with the data. Data gets auto-synced, and you have everything you need in one place. So that's basically how we do this. Yeah, and the last one is, that's our, just for fun, QR printer self-service. So this is a nice work by one of my colleagues. And you can basically type in the eLabFTW ID number and press a button, and it will automatically print you the QR code that you can directly stick on our sample boxes, and the size also fits. You could also print it from eLabFTW and then, you know, cut out the QR code, but people are lazy. So that's one idea how to do this. And I have to emphasize, this is completely offline, so you can type in whatever you want. If it's the wrong number, then the sample loading Raspberry Pi will just say, sorry, I could not find this in the eLabFTW database. Yeah, just quick outlook before we're done. Yeah, next one. So the next steps we have planned is to write like some sort of experiment manager to bundle the data on Void and eLabFTW in a nice way, and somehow get the database ID into the sample title. I don't know if that's possible. I know you have these custom IDs, but the sample ID would be great to put in there somehow. I don't know if this is possible. Yeah, and then handle a link to the data so we can, you know, consume it via an API. So I was thinking of using the JSON feature for that, but if you guys have better ideas, then I'm all ears. And what is also a topic for us is now handling this 4D STEM data that we record with our super high-speed cameras, because this is tons and tons of data. So we need to up our storage a bit. Yeah. That's it. I hope it wasn't overtime. And yeah, thank you very much for your attention and for showing my slides. Thank you very much.
Thanks so much, Clemens. That was really interesting. Does anybody have any questions? No, it was great. And we just had one question from someone about the storage space that you allocate for your data with eLab.
Yes. You mean the raw data storage for with our software-defined storage? Was that the question?
I think the question is just what is your system for data storage?
Yeah, so what we do is we do Ceph, which is a software-defined storage, which is you can think of it as a RAID over multiple hosts, and if you need more space, you just slap in more drives, and this is then mounted to a file server, and software-wise, the file server then exposes the files via SSH. So we do SFTP because it works nicely over the internet, and you can have this open to the internet and share this with anybody basically. Access is key only, so we don't deal with passwords and stuff. And all the data is strictly read-only because I think raw data has to be read-only and immutable. Yeah, Ceph is quite nice. The guys at CERN use it, and I always joke and say if it's good enough for CERN, it's good enough for us. Because you can basically expand it to petabytes and beyond if you have enough money for hard drives.
Cool. Okay, well, let's do one more question from Clemens. And then some people are asking, are we going to talk about the next version of eLabFTW? And yes, we will. And we will answer this question about folders in a second. But the question is just, did you have any issues so far with using QR codes?
Not really. I mean, they're read nicely, and we have a really, really cheap webcam on the Raspberry Pi because this system was more or less one of the COVID lockdown projects. And in the beginning, of course, webcams were kind of sparse. So I got like the crappiest webcam, cheapest, crappiest webcam, and it's good enough for that purposes.
Amazing. Okay, well, thank you so much, Clemens. Some people wanted the slides from your talk, so we posted those in the chat. And now we're just going to open the floor to general questions. So the first one is, we were wondering if we could organize our data in folders in eLab.
Well, this question often come back, and so I've written in the documentation why folders are not are less good, let's say, than organizing your work with tags. Let me just try to find the stuff. Yeah, how to have folders or project in grouping experiments. So I will put in the chat the link to this documentation, but basically the point is that when you have something in a folder, you can only have it in one folder. It can only exist in one folder. So if you want to have that, you can use the categories. Categories allow you to organize stuff in one thing. It can only belong in one category. But with the tags, you can really think of tags as folders, except one thing can now be part of several folders because they can be part of several tags. And if you use also the favorite tags feature that you can access by clicking on the left-hand side, well, and I can share my screen. I can show you. It will work really similar to a folder setup. I'll just write this. Yeah. So while I set up the share, we can go to the next question.
The next question is about release date and updates.
Yeah. So just to show you the favorite tags feature, you have this little option here where you can add a tag as favorite. So you start typing the name of the tag and then you add it to this list. And this list of tags then becomes some sort of left-hand tree-like stuff where you basically have a list of folders, but we can call them folders if we want, but they are just tags. And so they appear a bit differently than normal tags. They have a different background color so that they stand out, and they become your main tags, basically. And you can then browse your experiment by clicking on this tag. But you just need to add a few tags as favorite, and it works fine. So regarding the updates, we have in last days a bunch of updates that were released. So we have version 5.1.5, which was released 2 days ago, and before it was 2 weeks ago, and before a lot 2 weeks ago. And there will be a new one this week also, because we found a few bugs. And we could imagine like major release with new big features every 2 months, more or less. It's not really set in stone. And regarding the new features, so basically one thing that we're working on is the chemical structure editor that will be part of the new version. And I think my dev stuff is not working on Chrome. Okay, so yeah, it's a work in progress. But well, I will share the Firefox one then, because it's a pity if I cannot show you this. I will just try this. Chemical structure. Let's go. So this is the new editor. So for a long time, we had an editor that was a bit limited, but there is not tens of thousands of chemical editors that are open source that could be integrated in eLab. But these are the people behind the Indigo ELN, and they publish their chemical editor with an open source license. And this one is really much better than the other. It allows to do a lot of cool stuff, and especially things that would seem basic on the other editor, but was not possible. So here you can write some text that this is something you just could not do on the other, and you have a lot of templates and features and stuff. So it's really a super nice editor. You even have a 3D representation. I don't know if we can see it now. We cannot see it well. Okay, maybe 3D doesn't work well when you have an arrow. But yeah, anyway, this is like something that will be in the next version. And more importantly, we also will be able to search substructure. So if we start drawing something, and then we click here this button, search molecule, it will look into the existing database, so the resource database, basically, where you will have your chemical compounds, let's say. It will look into this database to see if you have already a molecule that contains the structure that you have drawn. So it will do a substructure search. And also, we will integrate better with the PubChem API, which contains reference to a lot of compounds, to make it easy to import things in the API via the PubChem, basically, so that you have all this information about the Inchi representation, maybe the smiles, like everything. Plus, also we will calculate the fingerprint, so that then we can do substructure search. So it's a bit involved, but hopefully it will be ready for the next version. And we will also improve on the storage possibilities of the resource, so that we can better define the physical place of where things are existing in real life, so that it could become easier to say, okay, show me all the chemical compounds that are in the room 318 of this building. And this, of course, is something that is linked with the security aspect and the safety and security aspect that you can want to have when you have a database of potentially dangerous products. You want to be able to list them easily and to extract that information quickly. Another thing also that we will be working on will be the DNA cloning feature which will be based on the share your cloning application, which is developed by Manuel Lera. And this allows you to enter to basically make some DNA modifications to do some cloning and everything on plasmids, and you will have a nice way to interact with the lab basically. So we will see how it goes, but it will be something probably useful for all the biology labs. So there will be some stuff for the chemistry lab, some stuff for the biology labs, and the physics people, they just can get around by themselves. But no, yeah, as you know, if you have a feature request, you know where to find us. Okay, so do we have some other stuff?
Yeah, there's a few more questions. One is about inventory management functionality.
Yeah, so this I talked quickly about it. It's on the way.
Cool. And then do you want to take this last question?
Yeah, how to reset the automatic ID of resources while uploading a CSV file, custom ID. Yeah, the custom ID currently it's a bit problematic that once it's set, when you delete the resource, it stays there because it has been set at some point in time, so it kind of takes the spot of it. So this is something that you can probably do with elAPI. So Mahadi, you now have something to work on, like clean up a broken CSV import that you do where the custom ID are taking the space. Are you planning a visibility setting for groups? So maybe so it depends what you are what you mean by that, because are you what? Okay. Are you okay? So this is like the old wait, maybe I just need to refresh this. Okay. So if you have some groups, if you have like many groups in the instance, there is this new setting which allows you to select if you want to list only the groups that you belong to in this block here, in this menu, or only the groups that were created in your team, or if you really want to list all the groups of everyone in the full university, depending on if it's useful to you to see them or not. So if this is what you are talking about, then yes, it's implemented already. And if you don't see it, it's because your university needs to update the version. Now, if you're discussing about having the visibility of here, the groups here, and being able to say who can see that, like inverting basically the responsibility of who can see what. No, this is not planned. I don't, yeah, for the moment, I'm not convinced it would be something that would need to be added.
Cool. Do we have any more questions? Maybe we're good. Well, thank you so much, Alexander, Clemens, and Amir, and also everyone for coming. The next meeting like this will be in 2 months. We haven't scheduled the date yet, but we will do it soon. And oh yes, we're on lots of social media. We're trying to be more active. I don't have all those links right now with me. Do you have them, Nicolas?
Yeah, I will post them in the chat. Yeah.
Okay. Thank you for doing that.
And we are on the Fediverse now.
Yeah,
Thanks
which
to the
joined.
Chapril. Fediverse, and yeah, follow us also on LinkedIn. Yeah.
Okay. So I'm going to save this chat. If anyone wants any of the links to slides, or if they miss anything, you can always contact me at sydney@deltablot.email. We're very responsive. And yeah, does anyone else have anything to say? Appreciate the Fediverse presence. Cool. Yeah. So we'll see you in all the different points of contact that exist. And if you're interested in speaking at the next community meeting, if you have something you'd like to share with everyone, get in touch because we'll begin scheduling that right away. So yeah, any closing remarks, Nicola?
Well, thanks everyone for joining. Even if a few left already, we reach, I think, 110 or something like this. So that's great. Thanks to the presenters also. It's really nice to see all this external integration and how people actually take the software in their hands and make it work to answer the problems that they have. So it's really nice to have these kind of meetings. Yeah, we wanted to ask the audience, would you be interested in having some sort of office hours that would be more regular, maybe once a week or once every 2 weeks, where there is no plan, no presentation, no anything. We are just here, we are connected, and then you can drop in and ask questions or discuss or see where we are with some features or whatever. Would that be something that you would like to see or not?
Yeah, sure.
Let's try it. Well, we won't do that. We'll probably launch it in the next few months. But yeah, I think that's something we could definitely try, and that could be fun.
Like a virtual coffee table.
Yeah, something like that. Yeah, like no stress, but just discussion. Thanks for the nice comments, Andrew. And goodbye, everyone. Have a great day, great week, great month, great year. See you around. Bye.
Bye.
Bye.